Remember that either could be the claim. This is H sub O and H sub A. All right, this is where things change. Instead of finding rejection region, there is no rejection region. This time we're going to go straight to finding the test statistic. Find the test statistic. That formula is, again, x bar minus mu over sigma divided by the square root of n. Okay, next up is to find the area or percent that corresponds to that z-score and compare to alpha. This is a p-value. Your p-value, if it is a left-tailed test, left-tailed or right-tailed test, it's equal to the area in the tail. If it's a two-tailed test, it's equal to the area in one tail times 2. Next, we're going to accept or reject the null. I'm going to reject if my p-value is smaller than alpha. And I'm going to accept if my p-value is greater than alpha. And what's the last step, do you think? Not the alternative. What do we care about? What's the point of this? The claim, yeah. Accept or reject the claim. It could be the alternative, but it could also be the null. Accept or reject the claim. And this is writing one sentence with context. Deep sighs on that one sentence.
How do you do the alpha? I can't figure it
Alpha, okay.
out.
Start here, watch me. Ready?
Wow.
So start kind of swooping it. Like, it's like you're making an infinity symbol, you just don't finish it.
I started
It's
the
really
bottom.
just here and then.
I started the bottom. I don't know. Yeah.
When I was little, I used to write 8s by doing a circle on top of a circle, and sometimes the circles didn't even touch.
My dad still does it.
So does my dad.
It's the better way.
I think I still make 8s that way, but they always, well, let's see. Yeah, I still make 2 circles, but they always touch now.
Mine is just a 6 with some extra stuff.
Just a 6 with some extra stuff.
It's
It's like a 6 with like some pizzazz, you know?
It is though, 'cause you go with a 6 and they just connect it.
Oh, you thought I was a 6?
Yeah. But you don't.
No, this time. No, this time. This time.
Show me how you do that, Ryan. I wanna see how you draw. Do it. Do you do that? Actually? Yes, I do.
You do it though, I wanna see, cause I just did it and it looks ugly.
Ryan,
I'm not-
It
write your
does,
whole
it does
alphabet
look
there.
ugly, but it's definitely 8 4.
Ryan, write your whole alphabet there, capital and lowercase.
I go like this.
Oh. I
Ah.
thought you were like actually like draw 6 here.
It
and then
is.
just like, no.
It's a 6.
Okay,
Alright, Cole, see this? It's a 6? No, it's an 8.
No, I did that. I thought you
Whoa.
meant just like here, take your pencil up and then go like that.
Jasmine is wondering what kind of nonsense is happening and why we can't get back.
You
We're
also
probably
do
on the 6th video right now and she's dying, okay?
Oh my lord.
Come on, let's do this. Example 3. In auto racing, a pit stop is when a racing vehicle stops for new tires, fuels, repair, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. Have you noticed that this is a really big deal in racing, how fast you can switch things over? A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds.
Wow.
Which is accurate, by the way. Like this stuff, I'm not saying that this one is correct. I'm just saying that they can do it that fast, yes. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. All right, so we've got a sample mean here of 12.9 seconds. We're assuming that the population standard deviation is 0.19. That's what tells us this is going to be a z-test. Is there enough evidence to support that alpha equals 0.01?
Wait, what tells us it's gonna be a?
Because it was a population standard deviation.
Oh.
That right there, that says to me z-test. If it was a sample standard deviation, that would be a t-test, which is what we're doing next lesson. Okay, so step 1, write the null and alternative. You guys still like having steps?
Yes, always.
Okay, null and alternative, here we go. What should I write? What's their claim?
Mu is less than
13?
13.
Yeah, should that be null or alternative?
Alternative.
Yes, mu is less than 13. That's our claim.
And then the other one is mu is greater than or equal to 13.
Mm-hmm. 12.9. Seems pretty darn close. But also when we're talking about just 13 seconds, maybe 12.9 is amazing. You know what I mean? And they've got also 32 here, samples. Like if I had, the bigger your sample size, the more likely it is to pass, even if it's close. Because if I had 1,500 sample times and the average was 12.9, that's looking like, yeah, it's probably less than 13. But if I had 2 sample times and it was 12.9, let's get some more data. You know what I mean? So next up, we're doing a finding out our z-score. We're gonna do x bar minus mu over sigma divided by the square root of n. Okay, so z equals 12.9 minus, where's my mu? 13.
Oh, wait, no, I was like this.
Yeah, you're looking at the standard deviation. 0.19 divided by the square root of, what was it, 32?
Yeah.
Now notice that this problem doesn't say that it's a normal distribution, but n is bigger than 32, so we can assume that would be about normal. Okay, all right, so in my calculator, 12.9 minus 13 in parentheses divided by parentheses 0.19 divided by the square root of 32. I got negative 2.98. That's my z-score. Okay, I'm going to draw a quick picture to remind myself what kind of test this is.